Trends in the alkali metals. Some of these trends we've already talked about. As we go down the column of alkali metals, what's increasing is the atomic radius. They're getting larger. Their density is also increasing, and the reactivity is increasing. What's decreasing is the ionization energy, the electron affinity, and the melting point. The melting point of those elements at the bottom, like cesium, very low for a metal. Metals generally have high melting points, but those larger alkali metals do not. The reactivity is definitely related to the decreasing ionization energy. So this very low ionization energy means they're good reducing agents because they're very easy to oxidize. Oxidation is loss of electrons. These guys are pretty willing to lose electrons. They're very reactive. We do not find alkali metals just sitting around uncombined in nature. You're not going to, have a sodium mine, right? Because sodium reacts with water. It's just, you don't find it. And their compounds are generally soluble in water. They react vigorously with nonmetals, such as the halogens. So if M is an alkali metal and X2 is a halogen, you end up with an ionic compound, like sodium chloride. They react explosively with water. Here's lithium reacting with water, and here's sodium, a small amount of sodium reacting with water. It generates hydrogen gas, and it generates enough heat that the hydrogen gas ignites. So lithium is reactive, sodium is more reactive, potassium is even more reactive. You can see it's actually just shooting stuff out, almost like a little fireworks or something. Halogens have some trends too. Again, we've got atomic radius and density increasing as we go down, and the melting point increases. What's decreasing is ionization energy and reactivity. The lower halogens, like bromine and iodine, are not as reactive as fluorine. They have very high electron affinities. They want to gain electrons, and so that makes them good oxidizing agents. Remember, an oxidizing agent causes something else to be reduced, right? So they're very easy to reduce. They're very reactive. They're not found uncombined in nature either, and their compounds are also generally soluble in water. They react with metals to form metal halides. We just kind of talked about that in terms of the alkali metals, but these guys will do it with lots of different metals. And they react with hydrogen to form hydrogen halides. So you can do some kind of cool stuff like that. Here's bromine at room temperature. It's a liquid, but it vaporizes quite easily, and it's kind of a brownish color. Chlorine at room temperature is a yellowish gas. Iodine melts at a fairly low temperature and will make this beautiful purple gas. Trends in noble gases. Yeah, it's the same trends. Exceptionally unreactive. They are only found in the uncombined state in nature. In fact, before 1960s, people believed that they didn't make any compounds at all. And still, the smallest three, helium, neon, and argon, nobody's made any compounds with them. And not for lack of trying, I'm sure.